Hi students, now we're going to do the last video about graph. Suppose you want to graph y equal ex. You all know x belong to R. We don't have impossible here. Ex, we know that ex is always positive. So this curve must be above, as you can see here, the x-axis. So limit as x tends to minus infinity, e power minus infinity is 0, y equals 0 horizontal asymptote. Infinity, it's infinity. The direction, if you do ex over ex, so variable exponential is stronger, so it's infinity, or you do Hospital's rule, ex over 1, so it's infinity, parallel curve to y-axis. And derivative is ex, so it's always increasing, positive, always ex. So going up, if you want to take particular points, x and y, if you take x to be 0, e power 0 is 1. If you want to take x to be 1, you have e, etc. So you have horizontal asymptote and going strongly. Why strongly? If you take, for example, 2, you're going to get 7 point, e squared. If you take 3, it will be the number will be bigger. And this y equal ex is symmetric with respect to y equal to x and will give us the logarithm. So that's why the weakest is logarithm, here logarithm, then the variable, and the strongest is the exponential. So that's why we say the exponential is stronger, because it is a very strong function. X plus e minus x, also x belong to R. I don't have denominator, and ex is always positive, exponential e minus x. So limit as x tends to infinity, you have infinity plus 0, infinity. The direction, if you divide by x, you have e minus x over x, exponential stronger. Why? Because here you have e power minus infinity 0, 0 over infinity 0, so plus 1. And if you do f of x minus ax, because x is 1 minus ax, it will be minus x. You're going to get only e minus x, and e power minus infinity 0. In that case, y equal to x is an asymptote. However, if you do limit as x tends to minus infinity, this is minus infinity, e power minus infinity, so infinity. So you need to put in factors. So we're going to put the strongest, which is e minus x. So I divide here by e minus x and here by e minus x. You're going to get 1. Infinity over infinity here, because minus and minus is a plus, so exponential is stronger. So this is 0. 0 plus 1 is 0. 0 times infinity is infinity. So in that case, we're going to do the direction. So we do f of x over x, so 1 plus e minus x over x. This is infinity over infinity, and you know that exponential is stronger. All you do Hospital's rule, so it's infinity. So since it's infinity, so at minus infinity, it's parallel to the y-axis. Derivative is 1 minus e minus x. Now, if you have plus, it's always positive, increasing. But since it's minus, you can equate it to 0. So e minus x is 1. So minus x equal ln 1, which is 0, and x is 0. So you have minus infinity 0 till plus infinity. Here, if you take a value which is bigger than 0, for example, take 10, 1 minus e minus 10, it's positive, this is negative, decreasing, increasing. If you replace here x by 0, you're going to get 0 plus e power 0, which is 1. And here you have y equal to x, it's an asymptote, and here the direction towards y prime y. You can take particular points as much as you want, you can use your calculator. So the behavior of the curve is going vertical, parallel to the y-axis, you have a minimum, and then going to y equal to x is horizontal asymptote. You can see it here, the curve, as we did it. Okay, so here the y equal to x, going from up, the 0, 1, and the asymptotic direction to y. Curve of ex over x, limit as x tends to infinity. This is infinity over infinity, which is infinity, but ax is stronger. If you divide it by x, certainly exponentially stronger. And if you do Hospital's rule twice, it will be infinity parallel to y-axis. If you do minus infinity, e power minus infinity is 0 over minus infinity 0, so you have y equal to 0. But the domain here, x cannot be 0. Why? Because you cannot divide by 0, so we do limit as 0 minus and 0 plus. If we start by 0 minus, e power 0 is 1 over 0 minus here, because it will be minus infinity, so x equals 0 vertical asymptote. If you do limit as x tends to 0 plus, you have 1 over 0 plus infinity. X equal to 0 vertical asymptote. Now derivative u over v, ex times, derivative of ex is ex times x, minus Derivative of x is 1 times ex, so you can put exponential in factor. So you equate to 0, you're going to get x is 1. So I have 0 impossible, vertical asymptote. You have 1. So if you take a number bigger than 1, you replace it here, it's positive, before negative. Going down, down, up. From minus infinity, as you can see here, you have y equal to 0, horizontal asymptote. Going down at 0 minus, it's minus infinity. 0 plus here, it's a plus infinity. If you replace by 1, it will be e. Going down, then going up, and going up parallel to the y-axis. So if you want to graph it, this is the form of the curve. Here you have y equal to 0 going to the vertical, then going up to the minimum and going parallel to y prime y-axis. You can take particular point as much as you want. Now the curve, the last one, f of x, you have 2x minus 1 e power x, limit as x, and x belong to r. Here we don't have denominator. As x tends to minus infinity times 0, exponential stronger 0, y equal to 0, horizontal asymptote. Infinity times infinity for limit infinity is infinity. The direction, if you do over x, here if you do the Hospital's rule, this will be 2ex, which is infinity, parallel to the y-axis. Derivative u times v, derivative of 2x minus 1, 2 times ex, plus derivative of ex is ex into 2x minus 1. You can put ex in factor. You have 2x minus 1 plus 2. You have 2x plus 1. You equate it to 0. It means 2x plus 1 is 0. X is minus half. If you replace by minus half using your calculator, you have this point. You have it going up. But how going up? You have y equal to 0. Here there is something wrong. Here you have y equal to 0, horizontal asymptote, and going, sorry, this is, it's going down, then going up, down like this, sorry, then going up. You have here minus 1.21, and how the curve looks like. Here you have y equal to 0, coming horizontal asymptote, then going vertical towards y prime y-axis. As you can see here, you can take particular point. This is the minimum, and going up. Thank you for listening. This was the exponential. Hope that you got the 3 videos.